Hello, ladies and gentlemen. Here is your Algebra 9 10.1 notes. We are looking at graphs and graphing square roots of functions. So we're going to take a look at that. Here are a couple warm-up problems for you for evaluating. So throwing in the 4 into there, what kind of answer do you get? And throwing in the 11, and what kind of answer do you get when you evaluate those? So a little warm-up. Couple terms here. We have radical expression. That is just an expression containing the square root. We have a radical function that we're going to be looking at. So it is a function that contains a radical expression with the independent variable in the radicand. And you can kind of see that down here in the parent function of the square root function. So here is the independent variable inside the radicand. Again, a function is when we have our f of x, g of x, h of x, or even the y equals, then we have our square root of x here. Square root function is just a type of function that we have. So obviously it's a function that contains a square root with the independent variable, and that is in the radicand. For our parent function also, when we're looking at this, we have our domain, which is going to be greater than or equal to 0. And we also have our range that's going to be greater than or equal to 0 here. So we're going to look at graphing these out and how they move around based on the parent function. So if I'm looking at here, this first one, I'm going to go ahead and graph out the parent function first here. So let me move that up just a little bit so I can see my green here. So when we graph out our parent function, I'm going to put that graph, where do I want to put that? Right here, why not? So this is my x, and then this is our end result. So this is our y equals square root of x, where we are going to get must be greater than 0. So our domain, so we have to start with 0, 1, 2, and 3. And then when we plug that in, when we plug in an obvious 0, you get a 0 back. If you plug in a 1, you get a 1 back. If you plug in a 2, you actually, I'm going to round to the 10th here. I calculated this earlier, 1.4. And then 3, there we're going to get about 1.7 on that answer there. So with that being calculated, we can graph out our parent function here first, and then we'll go and we'll do the new one. So parent function, square root of x, looks like this when we put values in, 0, 0, 1, 1, 2 and 1.4, so roughly about there, and then 3 and 1.7, so roughly right about there. And it is a swoop from there. And we'll keep on growing to the right and up. Notice here, we do not have any answers going this way. And this is where it starts, ladies and gentlemen. So there's always a starting point, and the graph grows, if you will, from there, depending on obviously which way the graph is being graphed out. So if we're looking at 2 or a number in front of the square root, how does that affect our graph? So I'll do this in blue. Again, the same x's, it's the same square root. Cannot put a negative in there. That's why we also start with 1, because you can't take the square root of a negative 1, because you get an actual I answer. And we aren't doing anything with I this year. I'll be in Algebra 2. So we have to start with 0. And you got your 1 and your 2 and your 3. And basically what's going to happen here is my answers, after I take the square root of that 0, 1, 2, and 3, I'm going to multiply by 2. So it's going to be very close to just doubling all of these. So yes, 0, 2. This does come out to 2.8. And then with rounding, this one actually comes out to 3.5. Doesn't quite double. Because remember, I rounded that answer before. So what happened? We got 0, 1, and 2. We got 2 and 2.8. It's right about there. And then 3 and 3.5. It's right about there. So obviously, when you have a 2 in front of our square root, very common when we're looking at our quadratics also, when we were looking in front of the parentheses and how quadratics moved also. If we have a 2 in front of here, this is going to be called a stretch, ladies and gentlemen. Remember, it's either a stretch or a shrink when we have the number in front of the square root. So we are going to get a stretch. And the factor on that is 2. They also want us to identify the domain and range of this one. And with just the number in front of our square root, the domain and the range are not going to change. They're going to be the same as what it was for our original. So x has to be larger than or equal to 0, which it started. Now the points are over here, greater than or equal to 0. And then our range, our y, is greater than or equal to 0 also, because, again, had the same starting point, and then just it rose a little quicker. So on our second one here, just a little change. Obviously, we have a minus sign. So what does that do when we use our points? So again, we're using the points 0, 1, 2, and 3. So obviously, put a 0 in there. 0 times anything is 0. 1 is going to be 1, but it's times a minus 2. So we're going to get a negative 2 answer. And you'll see we'll get the negative answers for the rest of them. So minus 2.8 and a minus 3.5. So from here, starting point 0, 0. Then we went 1 minus 2. Then we went 2 and minus 2.8. And then 3 and 3.5-ish. And we can see what our graph does now. When we have a minus sign, it actually is a reflection. Oops, how about reflection? And this is a reflection over the x-axis, and mathematically you always say reflection in the x-axis. And looking at, it is still a stretch there, ladies and gentlemen, even though it is a minus. It's stretching out. Remember your shrinks. Your shrinks are between 0 and 1 as a fraction. So again, we still have a stretch here. And factor is 2 again. And domain is going to remain the same because we're going obviously in a positive direction. So x is greater than or equal to 0. And then the range. That changed. Our y nows are less than or equal to 0. So a minus sign flips it, reflection over the x-axis, flips it over the x-axis, so we get all the y's that are less than or equal to 0. So let's see what happens now with a number on the outside, whether it's a minus or a plus. So again, with my table here. And again, I'm just going to steal my work from my original one. Here's my original one. So basically, I'm just taking it and subtracting 1 from the final answer. So we're going to go down 1 for all of that. So when we subtract 1 from all of those, we get, again, starting with 0, 1, 2, and 3. We get a -1, then we get 0, then we got a 0.4, and then a 0.7. So 0 minus 1, 1 and 0, 2 and 0.4, and 3 and 0.7. So what has changed here? We went down 1. So then our domain, oops, I don't need to spell out domain. We just use D. It's going to be X. Domain still is greater than or equal to 0. Our range has changed again. Our range now comes down 1. So that means Y has to be greater than or equal to that down 1. Down 1 is a -1. So, and you can start to see that and describe what is going on from the parent function without even having to graph this out. So, like for example, this one, I know if we went down 1, we subtracted 1 from all of these. Here, we're adding 3, which is actually adding 4 from this one, from our points 0, 1, 2, and 3. So we get, if I add 4 to this, we'll get an answer of 3, because again, we took away 1 from the parent function. So we're going to add 4 to get it back to a +3. And let's see, we're going to add 4. So that will be 4. And then we'll get 4.4 and 4.7. But again, not necessary to do this, not necessary to graph it out, because we're hopefully starting to see that, oh, numbers that are added or subtracted, move it up and down. If it's added, that's an up 3. And then I can go right into my domain. We did not and haven't looked at anything that moves it left and right at all. So X is going to be greater than or equal to 0. And your range is now going to be Y has to be greater than or equal to. We moved it up 3. So it has to be greater than 3. And in case you want the graph, just real quick, 1, 2, 3. And then there's the 4. And then 4.4. And then 4.7. Starting point. Last set of movements that we're going to look at for this section are, obviously, now we have things inside the radical. So how does a plus or a minus sign inside the radical move it from the parent function? So obviously this last part is a left or a right. And again, it's always opposite, just like we've been saying before with our quadratics and our linears. It's always opposite of what you're thinking. So opposite movement. So let's go ahead and graph this out. And again, just using a calculator for these. Now, one thing that is unique though is that our numbers have now changed that we can put in here. Used to be we just started out with 0 right away. Well, this is a +2. So if I put a 0 in there, I'm at +2. That means I can put a -1 in here and still get an answer that works in our radical. So what's the lowest number that will work? The lowest number that will work in this is -2, then -1, then our 0, and then we can count up from there. So if I put a -2 in there, we get an answer of 0. If I put a -1, that's 1. So that's going to be 0. Sorry, lost train of thought there for a second. And then when we plug in 1, that's when our calculator has to come in place. So that's the square root of 3, and that comes back out to 1.4. And now we're back on track to our answers before, and we get 1.7 for the next one. So how did this work? Graphing it, 1, 2, -2, and 0. And then -1. Oops, I made a little mental mistake here. That should have been 1, not 0. Sorry about that. When we put a -1 in here, we get 1 left over. So 1 square root of 1 is 1. So catch myself here. So -1 is at 1. 0 is 1.4. And then 1.7. And again, what do? We move this left 2. And then our domain is going to change now. This is the first time it's changed. So x is everything greater than or equal to -2. And then our range is back to what it was originally. Y is greater than or equal to 0 because we didn't have anything added to it. So again, the whole goal here, ladies and gentlemen, is so that you can look at this function and you can tell me what it is doing compared to the parent function. So you shouldn't have to graph this out at all. You should just be able to look at this and say, oh, that 2 in front of there, that is a stretch. Oops, spelled that wrong. We'll spell that right. And the factor was 2. The -1 tells me I need to go the opposite of that. So it's going to be right. Sorry about that. And that's going to be 1. And then we're going to go up 2. What you're going to see, the domain has a relationship here. So our domain is going to be x has to be, now, if we moved it to the right one, has to be greater than or equal to 1. And our range, that has to be, considering we moved it up, greater than or equal to 2. Thanks, ladies and gentlemen. As always, if you have any questions, please let us know.